Okay, so today is 12/11, December 11th. It's getting closer to break. Yay for all of us. Okay, so December 11th, we are going to do the next two sections. Today is 12/11, 2.3, unit rate and constant proportionality. We started talking about this already. This is on page 23. And then I think we're actually going to do the surfboards, commissions, markups, and discounts instead. We'll do this one. 12/11, and this is on page 32. Okay. All right, so those are the two items we're doing today. We're going to do the percent days together probably later on this week and early next week. Okay, before break. All right, so these two, 1 and 2. Not sure which one I like better. All right, so your homework for today will be page, we already did 52, so let's do 53 to 55. So comparing and scaling 2.3 and 3.1. Actually, let's do 55 and 63. And then we'll check to make sure that works. This will be due on Friday the 13th. Ooh, Friday the 13th. All right, so there we are, 55 and 63. All right, so let's go to 2.3. Oops, let's keep going. 2.3, where is it? Should be coming up soon. 2.3, gotta clear that page because I forgot to clear it last time. It's a fairly long section, but it's not too difficult, which is nice. And that should be it. All right, so 2.3 is today. We're on page 27. Page 27. At least in my book, we're on page 27. So page 27, December 11th, 19. Okay. All right, so there's a couple of vocabulary words here. Constant and proportionality. We've talked about this already before, and we'll talk about this again. Constant proportionality is a constant multiplier. Constant multiplier. Multiplier. That means if you multiply it by that number, you use it regularly. Okay. For example, in our last unit, okay, here's our example. We had pizzas. Example, our pizzas were the cost of a pizza. The cost of pizza was equal to the number of pizzas times number of pizzas times the cost, which was $12 per pizza. Our constant multiplier was 12. Okay, $12 per pizza. Okay. And we've actually defined unit rate in the last section, so we're just going to redefine it and write it down all nice and neat here. Our unit rate is a ratio with a value of 1 as a denominator. Ratio with the value of 1 in the denominator. Okay. For example, okay, here's your example $12 for every one pizza. This denominator is a 1. Therefore, this creates a unit rate. This is a unit rate. Right there. $12 for every one pizza. Good. You see unit rates all the time, and I mentioned this before. You might see a sign that looks something like this on your way to school, and it says 25 miles per hour. Okay, that road sign tells you the unit rate, the distance that you can travel for every 1 hour. Okay, and whenever you see the word per, okay, that means for every one, or for every, not necessarily one, because sometimes you can be per 10 or whatever. For every ... 1 unit, 10 units, etc. Usually every 1 unit. Okay, your constant of proportionality and your unit rate are usually the same, almost always the same. I'm just gonna leave that as same because they are the same idea. But the constant proportionality doesn't necessarily have to be a 1 in the denominator. It could be a comparison of two ideas. It doesn't always have to be 1. The unit rate always has to be a 1. Okay. All right. So fresh food. Let's go on with the first example. Fresh Foods has oranges on sale for 10 for $2. This represents your constant of proportionality. 10 for $2. But it's not a unit rate. So we can change it into a unit rate if we'd like to. For each part, find the unit rate. Oh, never mind. There we go. We do have to find the unit rate. That's red. Our unit rate. Actually, I'll make that green. Our unit rate. Be sure to label your answers with the proper units. Okay. Label. Super important. Make sure you know what's going on. What are you looking at? Okay. And you're labeling with the proper units. Make sure you're not paying $10 for 2 oranges, because if you do, then you're overpaying. Okay, what is the cost per orange? This idea here, this per orange, okay, even though it doesn't tell you 1 orange, that means for every 1 orange. For every 1 orange. Okay, we're making a unit rate so that there is 1 orange in the denominator. So let's write down what we got so far. Per orange, that means oranges go on the bottom, and then cost goes on top. Cost or money goes on top. We know that it is $2 for every 10 oranges. I don't know why I wrote oranges again. Our goal is to get down to 1 orange. Well, it's not $1. 10, that when it turns into 1, I know you guys want to say divide by 10, and I understand. I'm going to do multiply by 1/10. If you say divide by 10, that's okay. If they ask you for this scale factor and you say divide by 10, you're going to be incorrect. They are equivalent to each other. So divide by 10 or multiply by 1/10, they are the same. So $2 divided by 10 is 20 cents. 20 cents. Okay, 20 cents per 1 orange. This represents a unit rate. Okay, this is the cost per orange. Unit rate. Now that's going to be the same on the bottom, except for they change the way that they ask. This question says, how many oranges can you buy for $1? Okay, this time your unit rate still has a 1 in the denominator, except for they change it around. We now have cost. We'll change it to a darker purple. We have cost in the denominator, and we have oranges on top. Because in the end, we want to have $1 in the bottom, and we need to figure out how many oranges we can buy. Okay? All right. Our oranges are 10 for every $2. How does 2 become 1. Okay, the way that 2 becomes 1 is you multiply by 1/2, or you can divide by 2. Again, these are the same thing, okay, but only 1 represents scale factor. Okay, 10 divided by 2 is 5 oranges for every $1. 5 oranges for $1. Again, this also represents a unit rate. The word unit represents 1. Okay, there's 1 in the denominator. Okay, let me refer that off to the side. Important information. The word unit, okay, is represented by 1. Okay, unit means 1. A single unit means 1 item. Okay, now we're going to do the same thing, and these is what we call a rate table. And we've talked about rate tables. We've seen them before. Rate table, okay, that's this thing right here. Our rate table is a table of, this is the important part, equivalent rates. Now, they're not all unit rates, because not all of them have 1. This one has a 1, I know that. This one has a 1, so those become our unit rates because there are 1s, but the rest of them are not. Okay, we've already figured out how much we get for $1. Okay, that $1 goes there. So $1 is 5 oranges. So we can establish patterns along the way. Okay, we know that 1 orange cost 20 cents. Okay, and then 20 oranges. Well, there's a number of ways to solve this. And what I'm going to do is I'm going to show you using your unit rate, or using your unit rate. I go from 1 to 20. I'm going to use my unit rate of 1 orange. So I'm going to do oranges and cost, and I have 1 orange, and that's 20 cents, and I'm going to multiply them by 20. My scale factor is increasing my number of oranges by 20 and my money by 20. Okay, so I end up with 20 oranges is what I wanted, and 20 times 20 cents is $4. That's $4. Okay, you could have done 5 times 4 and 1 times 4. You could have done 10 times 2 and 2 times 2. Okay, you didn't have to use your unit rate, but because this unit's about unit rate, that's why I use that one. Okay, I'll do it again. Cost and oranges. Here's my cost, here's my oranges, because we go from 1 orange, which is 20 cents, and now we got to go to 11 oranges, so times 11 times 11, and we end up with $2.20. That's how you use your unit rates. Okay. Now, getting the 260 is going to be a little bit more difficult. Not a ton more difficult. What you notice is it's 40 cents more than 220, so it's just a little bit more than 11 oranges. So how do I get the 260? I'm probably going to use this one again, which is right over here, and make that into 26. Okay, so my 20 cents over 1 orange times, I'm going to say 13, will give me $2.60, because 2 times 13 is 26. And that gives me 13 oranges. Okay, using your unit rate to fill out your table. All right, you are gonna work on this page on your own. It should take you about 10 minutes or so. If you get stuck, come back to here, to the video, play it again, and see what you get. Okay. Actually, we're gonna skip question number 3. Skip number 3. All right, so you spent a few minutes on this, working on this on your own. That's the goal. You can't sit here and just watch the video and go all the way to the end. It's not going to be very helpful. It says, how does finding the unit rate help you answer the questions such as the ones below? How many oranges can you buy for $5? And how much do 25 oranges cost? Okay, you can use unit rates. You can use unit rates. Unit rates make it easier to scale up because they are based on the value of 1. Because they are based on a value of 1. Okay, so for example, we have the number of oranges. Okay, over $1 is equal to 5 oranges for every $1. That's our unit rate. Okay, and we could scale that up until we get the amount of money that we want, or we're looking to spend, and we can figure out how many oranges we got. Same thing with cost. If we have the other unit rate, which is cost for 1 orange is equal to 20 cents for every 1 orange. Okay, and I'm going to change this equation because this one's actually kind of confusing, and it's rarely used this way. I think they might have written it backwards. I'm going to say that this equation should be cost is equal to 20 cents, that's our unit rate, per orange, times number of oranges. Okay, so let me write that out. Cost, and actually I do this in blue. I always make this one blue. And we'll talk about that as we progress through the unit, is equal to 20 cents. Okay, that's our unit rate, times the number of oranges. Okay, number of oranges. Okay, this green part here, this is your constant of proportionality, and in this case, it's also your unit rate. Constant proportionality and unit rate. Constant of proportionality and also your unit rate. It is the cost for a single orange in this example. Okay, so what does the equation tell you about the relationship between the number of oranges and the cost of oranges? They're telling me the cost, this one tells me that the equation provides us the cost, based on the number of oranges purchased. Okay, so these are things you probably do, or your parents probably have to calculate regularly when they go to the store. All right, what is another equation relating these two same variables? Okay, so what we're going to do here is we're going to use something that you should have learned in 6th grade called fact families. Fact families is a huge part of math, and it really helps you as you progress through higher level thinking. Use equations that you know are true, and you just rearrange them. Okay, for example, our equation is cost is equal to 20 cents per orange, 0.20 times number of oranges, and I'm going to call that n. N equals number of oranges. Okay, and I'm just gonna rearrange that, and I'm gonna give you an example that you should know fairly well. It's just a regular multiplication problem. We can say that 10 is equal to, I don't know, we'll make this really simple, 2 times 5. 2 times 5. Well, I'm going to rearrange this equation and make another true equation. I'm going to say that 5 is equal to, using the same numbers, 10 divided by 2. 10 divided by 2. Red is equal to blue divided by green. I'll do the same thing over here. I can say the number of oranges is equal to our cost divided by our total cost divided by 20 cents. Okay, number of oranges is equal to the total cost divided by the cost per orange. Okay, so these fact families, I don't know if you guys remember these. These are very, very important. We do these all the time, all the way up into calculus and everything past this level. You have to be able to rearrange an equation. Okay, 10 equals 2 times 5. 5 equals 10 divided by 2. You can also say 2 equals 10 divided by 5. All those ideas are equivalent. Okay. All right, if you need to take a break and come back, work on number 4 once you're finished. I know it's getting a bit lengthy. I'm going to pause the video after number 4, and then we'll do the second part a little bit later. All right, so how does the constant proportionality relate to the unit rate? Okay, well, how does the constant of proportion... Okay, let's do this. Let's say that I have number of oranges, okay, and then I have cost per orange, okay, and all that, okay, if I multiply those together, that will give me my total cost. Actually, I'm going to put it on this side. Yeah, I'll put it on this side. This is our total cost. So we can say something like, if I were to purchase 5 oranges, 10 oranges, 12 oranges, I can figure out the cost by using my cost per orange. Okay, each orange cost us 20 cents. So I'm going to multiply 20 cents by each one of these. 20 cents, 20 cents, 20 cents. Okay, and they'll give us our cost. I'm not really concerned with this part, actually. This is $1, this is $2, and this is $2.40. Okay, I'm not really concerned about this part. Okay, this part is, they're asking, is your constant multiplier. Constant proportionality is our constant multiplier. What did I multiply by repeatedly here? Because no multiplication going on there. That's the product, our solution. What is constant on this side? The only item that's constant on this side is our cost per orange. Okay, this is, we are multiplying by each time. This represents our constant multiplier. Okay, our constant multiplier is the same as, or how we defined, this is how we defined our constant of proportionality. Okay, that's our constant of proportionality right there. It is our constant multiplier. Now, how does that relate to unit rate? These are the same. That's the cost per unit. This is also the unit rate. Okay, it is the cost per single unit. Okay, the total cost, I'll put here, C is equal to the number of oranges, that changes, and I used n before in this example, so I'll use it again. N times our 20 cents, our constant multiplier, okay? Constant of proportionality. That number doesn't change. These change. The number of oranges might change. Today I want 10, next week I want 20, the week after I want 1, and then my cost will change each week, okay? Actually, I'm going to finish this section, and then I'll take a break because I want to make just 2 videos, okay? So it says graph, I don't know why it says 2 equations. Oh, no, we're going to change this to 1 equation because we didn't talk about the other equation. We'll change this to 1 equation. And our equation was cost is equal to n number of oranges times 20 cents. Okay, that's our equation. Okay, so this graph, do not forget your title. Titling everything is extremely important, or else I will mark things wrong in your test because I don't know what your graph is telling me. This is the cost of oranges. Cost of oranges. All right, give it a try on your own first, and then if you are stuck, then come back and follow along with me. Okay. All right, we have cost, and that is equal to our constant multiplier, 20 cents, times the number of oranges, which I'll call n. I'm just going to stick to that number of oranges. Okay. All right. Now, in equations and graphs, costs are defined by the variable y. And the y-axis is over here. This is our y-axis. So this, I'm going to label cost. Okay. Anything that we get after an equation, here's our problem and here's our solution. Our solutions are called outputs. Okay, that's what we get out after we calculate what's going on. Okay, now what do I have to put in here? Well, yeah, there's the 20 cents here, but the part that I'm really inputting here is this n value, which I'll call our number of oranges. This is x, or at least x variable because that goes down here. Okay, number of oranges. Okay, this is our input. We input into the equation the number of oranges we need for our equation. This doesn't change, so that's not an input. It's just part of the equation. We put in number of oranges, we get the cost out. Okay, so this is our y, our cost in dollars, our y value. Okay, so if I buy 1 orange, well, if I buy 0 oranges, let's go with that first. If I buy 0 oranges, okay, it's going to cost me $0. Okay, if I buy 1 orange, I look at the x values first. If I buy 1 orange, I know that's 20 cents. It's kind of hard to get that one, but I'm trying my best. Okay, then if I get 2 oranges, we'll be at 40 cents, 60 cents, 80 cents, and then $1. Okay, this here is going to represent 1 orange, sorry, that's incorrect, 5 oranges there, and $1. And that $1 is represented there. Okay. All right, that is a coordinate point. It's 2 values, my x value first and then my y value. I'm going to skip a few because that's a lot of dots. And I'm going to get to 10 oranges is $2, 15 oranges is $3, and 20 oranges is $4. Okay, so this one represents 10 oranges. This one is 15 oranges. Okay, that's this number, that's this number, and this one is 20 oranges. And that's this number. The next one is going to be $2. This one is $3, and this one is, do I have space? Yeah, I have $4 here. Okay. Now, if I connect all these dots from here to there, okay, with a nice straight line, that represents my amount of change or my cost. Okay. So this shows you where your unit rate is. Okay, so let's zoom in really close as much as we can. Okay, here, unit rate, the idea of unit rate, this means 1 in denominator. Our denominators are defined by our x values in our rate. This means for every one change, so here's my change, 1 orange, let me change colors, okay, 1 orange, that is my unit, there's my unit rate, 1 orange, 1 orange. The amount of change that happens, that increases this way, is 20 cents, okay? That is how we visualize our unit rate. Every time I buy one more, my cost goes up. Every time I buy one more, my cost goes up. And it goes up at a constant rate, okay? This here is your unit rate. 1 orange goes this way, 20 cents goes up, okay? All right, I'm gonna stop our video there, and then we'll finish the rest of it in the next section.